Hey, you know, that was a great coffee break we just had. So, what's next?
Well, you know, I pulled this magic formula out of my back pocket. This one here that relates the sign of the sum of two numbers to sines and cosines. Let's explain why that's true.
I'd like to see what you've got up your sleeve.
Okay, so it's a little bit of geometry. We've got two numbers here, x0 and x. x0 is the place where we wanted to compute a derivative. So let's put it on our circle. This is the cosine of x0, sine of x0. You remember that this was related to the area here. The area was x0 over 2. But let's not worry too much about that at the moment. Let's worry about having a point x. So let's say cosine x, sine x.
And this gives us another little teeny pizza slice.
And let's see if I can draw that pizza slice. It goes up like that, right?
Right, and this pizza slice, x is really small.
X is really small because we were computing a derivative. So we like to think of it as a small wedge.
Yeah, the kind that you would not like to get if you were buying it in a pizza shop.
Now, in this formula, you see we have x naught plus x. So what I'd like to do is take this and kind of rotate it up to here. Can I draw a separate picture of that for you, Matt?
Yeah, let's do that.
So here's our x naught curve. And then I'm going to take this little wedge and just rotate it up here. Now this guy is the same. It's still cos x0, sine x0.
And now you got this area, and you're now adding this to it. So
That's right.
You're rotating by a little piece.
So we're rotating a little bit, and we have this area plus this area. So that gives me a new point, which has the sum of the two areas. So
Right.
that's adding up to x0 and x. So this point is actually cosine x0 plus x sine of x0 plus x.
Okay, so you got rotation. So you're taking really this point and you're rotating it
To this point.
to that point. So that means we know how to do rotations from geometry.
Right.
So let's do that and see what happens next.
So you remember from geometry, when we write rotations, we make a little 2 by 2 matrix. There's going to be a cosine.
Shouldn't that be x we're rotating at
Oh,
y?
well, let's check this out. Let's do a couple of things
we
have
could-
to be careful about. There's a minus sign somewhere. Matt, I'm going to quiz you. Where's the minus sign?
Oh,
go?
you'll have to remind me here.
Well, it either goes in front of this sign or it goes in front of that sign. The way I like to remember is I say if I take the vector 0, 1, it rotates. This vector rotates that way, and I better get a negative.
It's a
So this
negative.
better be a negative here.
That's right, yep. But
And
that's rotating x by x naught.
And why did I do that? Well, you see, if I take this little wedge and rotate it this far, how much have I rotated by? Did I rotate it by x or did I rotate it by
Well,
x
this
naught?
goes to here, so by x naught, yep.
That's why I put the x naught there.
Oh, you did it that way,
There
yep.
you go.
Okay, so now put in what we're
Now,
rotating.
this is the point that we're rotating. Cos x, sine x. And the result, okay, so this is the thing that we rotated. It rotates to here.
Yep,
So that equals cos x0 plus x. And the y component, sine of x0 plus x.
so when we won't do all the algebra, let's do it for this output, because that's what we have there.
Right. So what we do is we take this vector, multiply it by the bottom row. We're going to get sine x0 times cos x.
Oh, wow.
And then here, cos x0 times sine x.
So this is wonderful because it's not so easy to do this another way. And here we have rotation in the platform of areas, which is related to our whole analysis of derivatives. So we kind of close the loop here. And really, we can use this again. And we get a bonus. We get the cosine version of this by taking the first row times cosine and so on. So
So exactly right. So if we write that out, here we have cosine. times
Cosine.
Cosine. So
Cos.
cos x0. And what's it multiplied by, Matt?
Cosine x. And now the minus sign.
The minus sign. Sine x0 times sine x. This equals the top part here. So now we have the addition formula for cosine.
Now with that, that means we can do any kind of differentiation by doing combinations of what we know in rotations.
Exactly. And in fact, we can look at this, and maybe we won't do all the algebra, but looking at this, we can see the cosine at a point x naught will be minus sine of x naught.
Right. Okay, great. Let's go forward. What do you want to do next?
I want to introduce you to hyperbolic functions.
Hyperbolas. Oh, good. Let's try the hyper and see where we go.
See you next time.